Welcome to the MSBT. Welcome to the MSBT online learning platform. We bring you the most relevant content in the exciting digital format. Today we will be studying a very interesting module from applied mechanics, which includes topic centroid and center of gravity, where we will be studying some interesting facts about the centroid and center of gravity, and we will be practicing some examples based on it. So let's begin. Dear students, today we are going to learn module applied mechanics. In that particular module, we are going to study the topic centroid and center of gravity. The learning objectives of this topic is to understand the concept of centroid and center of gravity, then calculate the centroid of different composite lamina, then calculate the center of gravity of different composite solids. The learning outcomes of this particular topic is determine the centroid of geometrical plane figures, calculate centroid of given composite plane lamina, determine the center of gravity of given solids, determine the center of gravity of given composite solids. The utility relevance of this unit with respect to real life are children playing seesaw in the garden, man balancing his body on the wire rope, elephants standing on the ball in the circus, and boat is balancing in the water. For utility relevance, if you consider a cardboard and you try to balance that cardboard on the fingertips, it will move left, right, and it will balance it at a particular point. So that point is called as a center of gravity of that particular cardboard. The topic relevant of this particular centroid and center of gravity is important for solving the problems on moment of inertia in mechanics of structure and strength of materials. This topic is also important for calculation of direct and bending stresses, slope and deflection in theory of structures, and this is also important for stability analysis of structure in design of steel and RCC structure. So prerequisites of this centroid and center of gravity are: in mathematics you should know the calculation of area and volume, then in applied mechanics you should know the force system, then you should know resolution and composition of the forces, and equilibrium is also important as a prerequisite for this. Now we will discuss the concept of centroid and center of gravity. In this, if you consider irregular shaped lamina having a number of particles exerting its own weight, these weights are acting towards the center of the earth, and if you calculate the resultant of these all particles, you will get a point where all the resultant of all the weights are concentrated, so that this point is called as the center of gravity of that particular irregular shaped lamina. So now we can define the center of gravity as the point through which the whole weight or mass of the body is assumed to act irrespective of the position of the body. That is called as center of gravity. Solid such as cone, cylinder, spheres, these are the examples of center of gravity. After center of gravity, the next point is a centroid. So centroid is nothing but it is the point at which the entire area of the plane figure is assumed to act for all positions of lamina, is called as centroid or center of area. So if you take plane lamina. So this is a rectangle having plane lamina. Why it is called as plane lamina? Because this is having two dimensions, B and D, and the thickness is very negligible. So weight of this particular rectangle is very negligible. Hence we have to find out the centroid of this particular rectangle. So we will move towards the next important point, that is axis of symmetry. So the axis of symmetry is nothing but, if you take a plane lamina, so if I will divide this rectangle in two parts, if I will divide in two parts, equal parts, then the centroid of that particular rectangle is acting exactly on the symmetry of that particular section. Here we have shown the axis of symmetry for that. So this concept is very important to locate the centroid of a particular lamina. So now we will discuss regarding the reference axis. So reference axis is also important. In this reference axis, what you have to do, you have to assume a OX and OY are the reference axis, and from that reference axis you have to calculate X bar and Y bar for individual figures as well as composite figures. So this reference axis is very important for you for locating the centroids. Now we will discuss some geometrical figures, formulas for the geometrical figures. So the first is the rectangle. So this is a rectangle. So rectangle is having two dimensions, B and D. So if you multiply B into D, you will get the area, and its centroid is located at a distance B by 2 and D by 2 from the rectangle for X bar and Y bar respectively. Then we will discuss regarding the square. So this is a square. Square is having two same dimensions, A, and both the dimensions are A. So you can find out the area as A into A, and its X bar and Y bar is also same, that is A by 2. So the next figure is a triangle. So triangle is having area 1/2 base into height, and the X bar is located at a distance B by 3 from the base and H by 3 from the Y axis. Then the next important figure is a circle. So this is a circle. The area of this particular circle is pi r square, and you can calculate the X bar and Y bar. This is a symmetrical about both the axes, hence its value is D by 2. So that is the diameter. D is nothing but it is a diameter of the circle. So the next shape is a semicircle. Area of semicircle is pi r square by 2, and its X bar is calculated as r from the Y axis, and Y bar is calculated as 4r upon 3 pi from the X axis. So now we will discuss the next section, that is called as quarter circle. The area of quarter circle is calculated as pi r square by 4. The X bar of this quarter circle is 4r upon 3 pi from the Y axis. So this is 4r upon 3 pi is the X bar, and 4r upon 3 pi is the Y bar from the X axis. So this is the 4r upon 3 pi. Students, do you have any question?
Yes, sir. I have one question. Differentiate between centroid and center of gravity.
So it is a nice question. So centroid is defined as it is a plane lamina and having two dimensions, and center of gravity is defined as it is having three dimensions, that is length, breadth and depth. So in centroid, the total area of that particular figure is concentrated at a point. In case of center of gravity, the total weight or mass of that particular body is concentrated. Hope you will understand the answer.
Yes, sir. Thank you.
We will move forward for centroid of composite plane figures. So for this you have to consider two axes OX and OY are the reference axis, and you have to draw a irregular shaped plane lamina, and in that we have to consider three areas. So first area is A1, and the distance of A1 from Y axis is x1, and the distance from x axis is y1. Then for area A2, the distance is x2 from y axis and y2 from x axis, and for A3 it is x3 from y axis and y3 from x axis. So using this particular lamina, you can find out the centroid of that particular plane lamina as x bar from y axis and y bar from x axis. So for x bar and y bar calculation, the reference axis is important, and using this we have to derive the equations for x bar and y bar. So this we have discussed, A1, A2, A3, x1, x2, x3 also we have discussed, and then y1, y2, y3 are also discussed by us. Then you can calculate the total area A1, A2, A3 up to AN, and then using the Warrington's theorem, that is algebraic sum of the moment of individual areas about any axis of reference is equal to the moment of composite area about the same axis. You can take the moment along OY axis, and you will get a x bar as A1 x1 plus A2 x2 plus A3 x3 up to AN xn divided by total area. Then you can take the moment along the OX axis, and you will find this equation, and you will get y bar as A1 y1 plus A2 y2 plus A3 y3 up to AN yn divided by total area. Using these two equations, centroid of composite plane figures can be found out. So now we will discuss what is regarding the composite figures. So composite figures are nothing but it is the combination of more basic geometric figures such as rectangle, triangle, circle, semicircle. So some of the composite figures are widely used in engineering. These are equal angle sections, unequal angle sections, equal and unequal eye sections, channel sections, T sections, and trapezoidal sections for retaining wall, gravity dam, and earthen dams. Then we will move forward for centroid of composite areas with cut sections. So cut section is nothing but if you have to subtract a smaller area from the bigger area, if one type of section is subtracted from other section, centroid of such sections are calculated using the following equation, that is x bar is equal to A1 x1 minus A2 x2 divided by area, and y bar is A1 y1 minus A2 y2 divided by total area. So here you have to remember that you have to subtract the area of this particular circle from the rectangle. So the second term in the equation you have to remember it should be a negative. Students, do you have any question?
Yes. How to calculate the centroid of cutout sections?
So it is a nice question. So cutout section is nothing but we are subtracting a smaller section from bigger sections. So at the time of calculation of centroid, the moment of smaller section is considered as a negative. So you have to subtract the moment of smaller section from the bigger sections. So you will get the centroid of cutout sections. I think you understand the answer.
Thank you.
So students, now we will discuss center of gravity for simple solids. Our first solid is a cylinder. So this is a cylinder. It is having 3 dimensions. So area is there and height is there. So for this you have to calculate the volume. So the volume of this particular cylinder is pi r square h, and the x bar for this cylinder is r. From the y axis it is r, and y bar is h by 2 from the x axis. Then next is a right angle cone. So this is a right angle cone. So this cone is having a circular area at the bottom and there is a height. So volume of this cone is calculated as 1/3 pi r square h. The x bar of this cone is r from the x axis, and the y bar is h by 4 from the x axis, and r is the x bar from y axis. So the next is the sphere. So sphere is a solid sphere. So this is a sphere. So sphere is having volume 4 by 3 pi r cube, and as this is a symmetrical about all the axes, the x bar and y bar of this sphere is r radius of that particular sphere. Then hemisphere. So hemisphere is nothing but it is the half of the sphere. So this is a half of the sphere. So the volume of this sphere is 2 by 3 pi r cube, and the x bar of this particular sphere is r. From the y axis this is the x bar, and from x axis the y bar is 3r upon 8. So the next figure is a cube. So this is a cube. So cube is having all the dimensions same. So the volume of cube is calculated as v is equal to a cube, and the centroid is also calculated as a by 2 because it is having all the dimensions, it is having symmetry about all the axes. Hence the x bar is a by 2. So with the help of these simple solids, we can discuss the center of gravity for composite solids. So a composite solid is a combination of two or more basic solids such as a cone, cylinder, sphere, etc. So this is a one composite solid having cylinder at the base and cone at the top, and this is second which is having cylinder at the base and sphere at the top. So you have to calculate the center of gravity for these types of composite solids. So this can be calculated, that means center of gravity of composite solids is found out using same way as that of plane figures. The only difference is in case of solid bodies, volumes are calculated instead of areas. So the center of gravity of solid composite sections are calculated using equations. X bar is equal to V1 x1 plus V2 x2 plus V3 x3 up to Vn xn divided by total volume. Then Y bar is equal to V1 y1 plus V2 y2 plus V3 y3 up to Vn yn divided by total volume. So V1, V2, V3 are the elementary volumes of the figure, and x1, x2, x3 are the distances of CG from y-axis. y1, y2, y3 are the distances of CG from x-axis. So here you have to consider volume. In centroid we are considering the area. So we can calculate total volume V is equal to V1 plus V2 plus V3 up to Vn. Then we will discuss center of composite solids with cut solids. So we have to discuss the cut solids. That means what you have to do, there is a cylinder is there. So from this cylinder you have to subtract or you have to remove this particular cube. Okay, so this is called as cut solids. So if one type of section is subtracted from other sections, the CG for such sections are calculated using the following equations. So x bar can be calculated as V1 x1 minus V2 x2 divided by total volume, and y bar can be calculated as V1 y1 minus V2 y2 divided by total volume. Here in second term what you have to do, you have to subtract V2 x2 and V2 y2 because we have to remove this particular cube. Students, do you have any question?
Yes, sir. I have one question. What do you mean by frustum of cone?
So this is a nice question. So this is a cone, okay. So if you cut this particular cone, the top portion of cone you will cut, so you will get a frustum of the cone. So this particular portion is called as a frustum of the cone. I think you understand the answer.
Yes, sir. Thank you.
So students, we have covered these objectives. So first objectives are to understand the concept of centroid and center of gravity. Then we have calculated the centroid of different composite lamina. Then we have seen how to calculate the center of gravity of different composite solids. So students, now you are fully competent to solve the problems of centroid and center of gravity. So worksheet is given below. Try to solve it. The solutions of worksheet is provided for cross verification. Let's see the solution of this particular problem. So first of all, you have to convert these two composite figure in three diagrams, that is triangle, rectangle and semicircle. Then consider x and y axis as the reference axis and calculate the areas for triangle, rectangle and semicircle using the basic formulas. Calculate the area of composite figure, that is A1 plus A2 plus A3. Then you have to calculate the distances of centroid for basic figures from the reference axis. So here this particular step is very important for this particular problem because students are doing the mistake while calculating this x1, x2, x3. Okay, so here what you have to do, here you have to calculate the x1, that is the x1 is nothing but it is the CG of this particular triangle from y-axis. So x1 is calculated as it is 200 minus h by 3. So 200 minus h by 3 is your x1. Then you calculate x2. So this x2 is 200 plus 400 divided by 2. That is the CG of this individual rectangle. Then you have to calculate the x3. So x3 is calculated as 200 plus 400 plus 4r upon 3 pi. So this 4r upon 3 pi is nothing but it is the centroid of semicircle. So from this you will get x1, x2 and x3. Then you have to calculate the distances of centroid from x-axis, that is y1 as h by 3 for triangle, y2 it is 200 by 2 and y3 that is semicircle, it is a radius is equal to 100 mm. Then you have to calculate the centroid of composite figures from y-axis, that is x bar you have to calculate using the equation a1x1 plus a2x2 plus a3x3 divided by area, and after doing the calculations you will get the x bar as 386.822 mm from y-axis. So here you have to do the calculations properly on the calculator, so there will not be any mistake. Then we have to calculate the centroid for composite figure from x-axis. So that is y bar you can calculate using this equation, and you will get the y bar as 94.24 mm from the x-axis. Now we will see a second problem. So this particular problem is a cutout section for plain rectangular lamina. So in this section, in this problem, you have to convert this composite figure in two diagrams. One is rectangle and second is triangle. So after considering x and y axis, you have to calculate the areas A1 for rectangle, A2 for triangle. Then you have to calculate the area of composite figure. So as we know that this is a cutout section, so what you have to do here, you have to subtract this particular A2 from A1. So you will get the total area. So then calculate the distances of centroid from y-axis. So due to symmetry, that this particular diagram is symmetrical about y-axis, the x bar is calculated as 400 by 2, which is 200 mm. So here you can see this is 400 divided by 2. This is the axis of symmetry. So directly you will get x bar as 200. Then you have to take care at for the calculation of this y1 and y2. Okay, so y1 is considered as it is 800 divided by 2 from the base, and y2 is nothing but, here what you have to do for this triangle, you have to subtract this h by 3, that is 1 by 3 into 300, so that is 100. So total is 800. So you will get 800 minus 100, you will get y2 as 700. Then you have to calculate the centroid of composite figure from x-axis, that is y bar, a1 y1 minus a2 y2 divided by area. So you will get y bar as 330.77 mm. Then we will see the next problem. So this is your next problem. It is having composite sections, that is one is cylinder and second is a hemisphere kept inverted on the cylinder. So you have to convert this figure into two parts, that is part 1 is hemisphere and part 2 is a cylinder. So this is a problem of solid sections. So here you have to calculate the volume of hemisphere, that is 2/3 of pi r cube. So you will get the volume of hemisphere. Then you have to calculate the volume of cylinder as pi r square h. So you will get the volume. Then you have to calculate the total volume of composite solid. So it will be V1 plus V2 and you will get the total volume. Then next important step is you have to calculate centroid of individual figures and composite figures. So here there is a axis of symmetry parallel to y-axis, hence your x bar will be directly getting as 200 divided by 2, that is 100 mm. Then we can calculate the distances of hemisphere, that is this is the distance we have to find out. So this is a y1. So y1 from x-axis we have to find out as this is 400 plus what we have to do here, you have to subtract this r minus 3r upon 8. So CG from the base for hemisphere is 3r upon 8, hence you have to calculate this r minus 3r upon 8. So total y1 you will get 400 plus r minus 3r upon 8. Then you have to calculate y2 as total 400 divided by 2. So in this problem, this particular term is very important, that is 400 plus r minus 3r upon 8. Here the students are doing the mistakes, so you have to be careful at the time of calculation of y1 and y2. After that you can calculate the y bar from x-axis, that is v1 y1 plus v2 y2 divided by total volume. So you will get the y bar as 237.5 mm. Then we will see, this is the next question. So in this question they have asked to calculate the volume they have asked to calculate the center of gravity of this particular frustum. So this is a frustum. Okay, so this is the bigger cone and this is the smaller cone. So for first you have to calculate the volume of bigger cone, then you have to calculate the volume of smaller cone. Okay, and then before calculation of V1 and V2, first of all you have to calculate this particular D. Using similar triangle law, that is 500 divided by 200 is equal to 250 divided by D, you will get the diameter of smaller cone as 100 mm. Then you can calculate the volumes of bigger cone, that is 1/3 pi r square h will be the volume of bigger cone, and you can calculate the volume of smaller cone, that is 1/3 pi r square h, and you will get a total volume. Okay, so this particular figure, this particular solid is having symmetry about y-axis, hence we will get the x bar as 200 by 2, that is 100 mm. Now you have to calculate the center of gravity from x-axis. So first you calculate y1 as h by 4 for the bigger cone and for y2 for a smaller cone. So for smaller cone, 250 plus h by 4. So this here h is a height of smaller cone. So you will get y2 as 312.5 mm. After this you have to calculate the y bar. So this is a cutout sections, hence the equation will become V1 y1 minus V2 y2 divided by total volume. So you will get a y bar as 98.24 mm. Now we will see some tips and tricks with respect to centroid and center of gravity. So the centroid is a two-dimensional figure, hence area is considered to calculate the centroid. Then center of gravity is a three-dimensional figure, hence volume is considered to calculate the center of gravity. If the vertical line of symmetry is there about y-axis, the value of x bar can be calculated directly. If horizontal line of symmetry is there about x-axis, the value of y bar can be calculated directly. The centroid or center of gravity is nothing but the first moment of area or volume about the reference axis. And in this particular, you have to remember the basic formulas of solid sections as well as formulas regarding the areas. You have learned some important topics so far, and we hope you had a good time learning with us. Browse through our online library for more content on MSBT website. Thank you, stay connected and happy learning.